Hello, good morning, everybody. How do you feel now? Have you gone through the numerical problems? Additional two problems were given and asked you to practice. Are you practicing? Hoping so. We will continue with the grade compensation. It is a reduction in the gradient when a vertical curve is likely to be provided on horizontal curve. Already curve resistance T into 1 minus cos alpha is required to be negotiated by the vehicle. In addition to that, there will be more drag if vertical alignment also is provided, or vertical curve is also to be provided. Hence, there must be some reduction in the gradient. That reduction is known as grade compensation. The grade compensation can be defined as the reduction in the gradient at the horizontal curve because of the additional tractive force required due to curve resistance. Due to curve resistance T minus T cos alpha, that is nothing but, as I said, T multiplied by 1 minus cos alpha, which is intended to offset the extra tractive force involved at the curve. IRC gives the following specification for the grade compensation. Grade compensation is not required for grades flatter than 4%. If the gradient is flatter than 4%, there is no necessity of grade compensation because the loss of tractive force is negligible. There will be loss, but it is very negligible. Hence, grade compensation is not at all required. Grade compensation is (30 minus R divided by R%). Value of R is the radius of the horizontal curve in meters. The maximum grade compensation is limited to 75 divided by R. This is 30 minus R divided by R. 30 minus R divided by R, where R is the radius of the circular curve. Similarly, another condition is the maximum grade compensation is limited to 75 by R. What do you mean by these 2 points? You calculate first from this formula, and also you have to necessarily calculate using this formula 75 by R. If calculated one is greater than this, then you limit to this value. If this is less than this, then take this value. That's all the meaning of these 2 points suggested by IRC, Indian Roads Congress. You see, horizontal curve and also there is a vertical curve. You can feel there is a vertical curve also and horizontal curve also simultaneously, the two with serpentine curve. Serpentine curve means S curve that you have studied in surveying 1 at SE level. Horizontal curve and vertical curve, the two serpentine curve. It is very dangerous and severe and difficult and discomfort for the driver to drive the vehicle. That is the reason why grade compensation is very, very essential part. Now, example. While aligning a hilly road with a rolling gradient of 6%, a horizontal curve of radius 60 meter is encountered. Means there is already a horizontal curve of radius 60 meter. Now, while aligning the hill road, we are required to provide a rolling gradient of 6%. Then find the compensated gradient at the curve. Solution, very simple, of course. Very simple. Rolling gradient given 6%. Grade compensation is equal to 30 plus R divided by R. 30 plus 60 divided by 60 you will get 1.5%. Maximum limit of grade compensation is 75 by R, that is 75 by 60, it is 1.25. Therefore, compensated gradient must be taken equal to 1 point by subtracting 1.25, not 1.5. Since 1.5 is greater than 1.25, you have to consider 1.25, not 1.5. This should not be considered. This should be considered. Therefore, compensated gradient is equal to ruling gradient minus grade compensation 1.25. That is worked out to be equal to 4.75%. Is it clear? I hope it is cleared. Just you have to carefully observe and watch and listen. Then there will not be any problem of solving such problems. So thereby vertical alignment, horizontal alignment is totally completed. Now we shall see the last article in this unit, highway drainage. Why it is necessary? Because whenever the water comes on pavement, by any means, usually rainfall we consider. Fog, we need not have to worry. At every location, fog will not present. Thereby only during rainy season, it is the problematic one. As soon as the water comes on the pavement, we should see that it is rolled down. Where to? Onto the side drains. How it is? By providing a suitable camber. That is the reason why camber or cross slope is necessarily to be provided to roll down the water. Once it is rolled down, where it goes? It has to find some way. For that purpose, drainage structure is required to be constructed suitably so that it will not spoil the other area nearby whenever the water is rolled down from the pavement. Okay, this is just introduction. Now, what are all the various articles to be studied under highway drainage? Introduction part, significance of drainage, requirements of highway drainage, surface drainage, methods of surface drainage, shoulder drainage, because once the water is entered into the shoulder, that is also to be drained off. For that, drainage is necessary. Median drainage, subsurface drainage, methods of subsurface drainage, and road construction in waterlogged areas. This is more troublesome to the civil engineers. Whenever the road are to be constructed in waterlogged area, it is very, very difficult. However, there are new technologies, methodologies, construction machineries, and different materials like geotextile, etc. are available. By making use of these new trends, it has become easy for the engineer to go for drainage structures. What is highway drainage? Highway drainage is a process of removing and controlling excess surface and subsoil water within the right of way. So whatever the right of way specification which you have already studied under geometric design, that will come into play now. It includes interception and diversion of water from the road surface and subgrade. Not only road but subgrade also. So when it comes to the subgrade, from where it is to be drained, subsurface drainage. When it comes on the pavement, it is surface drainage. That's why drainage includes both surface drainage and subsurface drainage. That is the meaning of drainage and why it is required. Now, significance of drainage. Excess moisture in soil subgrade causes considerable lowering of its stability. We know whenever the water comes comes into contact of soil, soil loses its strength, means stability is reduced or lowered. Increase in moisture causes reduction in strength of many pavement materials. Not only soil, other materials also, when they are wet, it loses its strength, like stabilized soil and water-bound macadam. WBM road. Naturally, when it comes into contact with water, it loses strength because soil around the aggregates will be lost. Thereby it loses its strength. Aggregates will start coming out of the pavement or the road surface. Thereby there will be loss in the material. Thereby voids will become more and soil will be get packed and it absorbs moisture, that is water, and loses its strength. Next point, sustained contact of water with bituminous pavements causes failure due to stripping of bitumen from aggregates, like loosening of detachment of some of the bituminous pavement layers and forms potholes. You must have observed soon after the rainy season or during the rainy season, water will be stored in the form of a pot. That is nothing but potholes. Excess water on shoulders and pavement edges causes considerable damage to the pavement. In clay soil, variation in moisture content causes considerable variation in volume of subgrade. Depending upon the type of soil present in the subgrade, there will be increase in the volume because of absorption of water. Until unless we remove the water from the subgrade, it may not quite possible to obtain or retain the same strength with which it was designed and constructed. High moisture content causes increases in weight and thus increase in stress and simultaneously reduction in the strength of soil mass. Could you understand this? As the moisture content increases, which causes increases in the weight and thus increase in the stress and simultaneous reduction in strength of soil mass. So as to reduce this, so as to increase the strength, water is required to be made nil. Erosion of soil from top of unsurfaced roads and slopes of embankment cut and hillside is also due to surface water. That's why surface water also is to be removed through surface drainage, whereas subgrade water in the subgrade or water from the subgrade should be removed. That comes under subsurface drainage. In cold regions, presence of water in the subgrade and a continuous supply of water from the groundwater can cause considerable damage to the pavement due to frost action. So these are all several points of significance of drainage, why it is necessary and essential part of highways. Now, requirements of highway drainage. What are the various requirements? The surface water from the carriageway and shoulder should effectively be drained off without allowing it to percolate to the subgrade. Means subgrade should be kept dry always. For that, there should not be any percolation of water from the surface into the subgrade. That care should be taken. That is the first and foremost requirement. Second, surface water from adjoining land should be prevented from entering the roadway. Suppose if water is flowing on either side of the road, from the side it should not enter onto the pavement surface. Side drain should have sufficient capacity and longitudinal slope to carry away all surface water collected. That means insufficient capacity of side drains and less longitudinal slope or improper slope in the longitudinal direction, water will not be carried away, which is collected from the surface. Fourth point, flow of surface water across the road and shoulders and along the slope should not cause formation of cross ruts and erosion. If the movement or flow of water is become vigorous, then naturally it erodes the material or erosion or removes the material from position. That should not happen. That's why shoulder and as well as road should be kept away from this contact of water from the surface. Seepage and other sources of underground water should be drained off by the subsurface drainage system. Highest level of groundwater table should be kept well below the level of subgrade, preferably by flowing is likely to occur. Highest level of groundwater table should be kept well below the level of subgrade, preferably by at least 1.2 meter. Last point, in waterlogged areas, special precautions should be taken, especially if detrimental salts are present or if flooring is likely to occur. That should be avoided. Next, surface drainage. During rains, part of the rainwater flows on surface and part of it percolate through the soil mass as gravitational water until it reaches the groundwater below the water table. It's a very important point. During rain especially, part of the rainwater flows on surface and part of it percolates through the soil mass as gravitational water until it reaches the groundwater below the water table. In case of cement concrete road and high quality bituminous concrete road, percolation is almost negligible. Especially in case of cement concrete road, it is nil almost, we can say. Whereas in case of WBM, gravel road, earth road or mud road, naturally it is pervious, therefore percolation is too much to reach the subgrade within no time. That is the reason why the surface water should be drained off quickly by providing suitable camber as per IRC recommendation and specifications. Removal and diversion of surface water from the roadway and adjoining land is termed as surface drainage. These questions may be asked for single mark. What do you understand by the term surface drainage and subsurface drainage? Just you have to write removal and diversion of surface water from the roadway and adjoining land is termed as surface drainage. Thereby we can keep subgrade and pavement surface in dry condition. You can add that sentence. It is not added here. It is understood. In order to keep dry only, we will remove the water. Diversion and removal of excess of soil water from the subgrade is termed as subsurface drainage. Here it is a mistake one. It is subsurface drainage. Subsurface drainage in the subgrade. Whereas from the surface, it is surface drainage. Okay. Methods of surface drainage. There are so many methods. By longitudinal side drains, by catch basins and inlets in urban areas. In urban area, everywhere we may not be able to provide longitudinal side drains, then we will provide catch basins and inlets in urban area. Providing damp-proof cores, we can provide a layer of blanket, bituminous blanket, or nowadays we are getting geotextile material, very good material. It is non-degradable also and economical also. Researchers pointed out that it is a very good material which can be used as a damp-proof course. Providing proper camber, providing sufficient slope to the sides, keeping the level of carriageway at least 60 centimeter above the high flood level HFL. These are all the points or methods of surface drainage we have to follow vigorously. Next, side drains for road in embankment. We will see in the next class. Thank you.